In April 2026, the Linux kernel, the software running everything from Android phones to supercomputers to the servers behind most of the internet, quietly added a new file to its official documentation. It wasn't a driver update, it wasn't a security patch, it was a policy document, and it drew a hard line around a type of code that has become part of daily life inside Microsoft, one of the largest software companies on Earth. To understand why this matters and why it's such an uncomfortable moment for Microsoft, specifically, we need to look at what the Linux kernel actually did, why it did it, and just how deeply Microsoft has built AI-generated code into its own everyday development process. Let's start with what actually happened, because the real story is more interesting and more nuanced than a simple ban. For years, contributing code to the Linux kernel has followed a strict, well-documented process. Every single patch submitted to the kernel has to go through the Developer Certificate of Origin, a legal mechanism where a human developer signs off on a patch to confirm they have the right to submit it and that it doesn't violate anyone's copyright or licensing terms. This signed off by tag isn't a formality. It's the legal backbone that lets thousands of companies, from Google to IBM to Microsoft itself, safely build products on top of Linux without worrying about hidden legal landmines in the code. By early 2026, artificial intelligence coding tools had become deeply embedded in software development everywhere, including inside the kernel community itself. Developers were increasingly using large language models from companies like OpenAI, Google, Anthropic, and Meta to help write patches, find bugs, and speed up their workflow. And that created a problem the kernel's own legal and technical structure had never had to deal with before. What happens when the code wasn't written by a human at all? Greg Kroah-Hartman, the maintainer of the Linux stable kernel and one of the most senior voices in the entire project, had been tracking this shift closely. He described a very specific and telling turning point. For months, kernel maintainers were mostly dealing with what the community started calling AI slop. Low-quality, often nonsensical security reports and patches generated by AI tools with little to no human review behind them. It was frustrating, but manageable. And in Kroah-Hartman's own words, it was even a little funny at first. Then, around February 2026, something changed. The quality of AI-generated contributions shifted almost overnight, and kernel maintainers started receiving reports and patches that were genuinely useful, technically sound, and worth taking seriously. That shift is exactly why the kernel community didn't do what a lot of headlines have implied. They didn't ban AI-generated code outright. What they actually did was more calculated and in some ways more significant. They wrote down for the first time an official policy governing exactly how AI-assisted code is allowed to enter one of the most important pieces of software on the planet. The new document lives at a very specific location in the kernel's official documentation tree. documentation/process/codingassistance.rst. It sits right alongside the kernel's long-established coding style guide and its patch submission guidelines. In other words, it's not a side note. It's now treated as core process documentation, on the same level as the rules that have governed kernel contributions for decades. So, what does the policy actually say? This is where the banned framing and a lot of coverage gets interesting, because the policy doesn't ban AI tools from being used. Developers are still completely free to use GitHub Copilot, Claude, or any other AI coding assistant to help them write kernel patches. And what the policy bans is something much more specific and much more consequential. AI systems are explicitly prohibited from adding their own signed-off-by tag to a patch. Only a human being can legally certify the Developer Certificate of Origin. An AI model, no matter how sophisticated, cannot take legal responsibility for a piece of code because it isn't a legal person, and it can't be held accountable if the code turns out to violate someone's copyright or contain a hidden vulnerability. In place of that, the kernel introduced something new, an assisted by tag. If a developer uses an AI tool to help generate or shape a piece of code, they now have to disclose it, formatted as assisted by, followed by the name of the AI agent and the specific model version, along with which tools were used. It's a transparency mechanism, not a prohibition, but it comes bundled with a much heavier requirement sitting right underneath it: full human accountability. The developer submitting the patch is completely responsible for every single line, regardless of whether an AI tool helped write it. The AI made it that way. It is explicitly called out in the documentation as not being an acceptable excuse during code review. This is a genuinely important distinction, and it's worth sitting with for a second, because it reframes what actually got banned here. What the Linux kernel banned isn't AI-assisted coding as a practice. What it banned is a very specific type of code that has become extremely common across the software industry over the last couple of years. AI-generated code submitted without meaningful human review, verification, or accountability attached to it. Code where a developer essentially takes what an AI model produced, doesn't fully check it, and pushes it forward as if it were their own carefully considered work. In the kernel community, that pattern earned its own nickname, vibe coding, and it's exactly the pattern this new policy was written to stop. And this is where Microsoft comes into the picture in a way that's hard to ignore. Microsoft isn't just a company that uses AI coding tools occasionally. Over the past few years, Microsoft has made AI-assisted development, specifically through GitHub Copilot, the AI coding assistant it owns and operates, a central, actively encouraged, part of how its own engineers write software every single day. GitHub itself, the platform where the Linux kernel's own source code is mirrored and where millions of open source projects live, has been owned by Microsoft since 2018. Copilot was built by GitHub and Microsoft specifically to sit inside a developer's editor and generate code suggestions in real time as they type, sometimes a few lines, sometimes entire functions, based on the surrounding context. Microsoft has spent enormous energy publicly promoting Copilot's role inside its own walls. It's used across Microsoft's own product teams, folded into internal engineering culture, and marketed heavily as proof that AI-assisted coding isn't just viable. It's the future of how software gets written at scale. That's precisely the category of code the Linux kernel's new policy is drawing a hard line around. AI-generated code accepted into a codebase without the kind of rigorous, individually accountable human review the kernel now formally requires. To be clear, this doesn't mean Microsoft engineers are somehow banned from contributing to Linux, or that Copilot-assisted patches can never be accepted into the kernel. Microsoft is, in fact, one of the largest corporate contributors to the Linux kernel in the world, employing kernel developers who work full-time on things like Hyper-V support and Azure-related kernel code. Those contributions still go through the same review process as everyone else's. What the new policy actually threatens isn't Microsoft's ability to contribute. It's the specific workflow pattern that companies like Microsoft have spent years encouraging internally. Developers leaning heavily on AI-generated output and moving fast, sometimes with review that's lighter than what a project as security critical as the Linux kernel now formally demands. The tension becomes even sharper when you look at why the kernel community felt this policy was necessary in the first place. It wasn't a hypothetical concern. Crowa, Hartman, and other maintainers had been watching an increasing volume of clearly AI-generated bug reports and patches flood in. Reports that looked superficially plausible, used the right technical vocabulary, but fell apart under any real scrutiny. This wasn't unique to Linux either. Daniel Stenberg, the founder of the widely used curl project, had already gone as far as temporarily suspending his project's bug bounty program because of the sheer volume of AI-generated junk reports overwhelming his ability to review real security issues. Seth Larson, from the Python Software Foundation, had flagged the exact same pattern hitting Python's own security infrastructure. In other words, this wasn't a story about one grumpy open-source maintainer being annoyed at new technology. It was becoming an industry-wide operational problem, hitting some of the most foundational, widely relied upon software projects on the planet, all around the same time. It also helps to understand why the kernel community reacts this strongly to trust violations in the first place. Because this isn't the first time unreviewed or misrepresented contributions have caused a genuine crisis inside the project. Back in 2021, researchers from the University of Minnesota deliberately submitted patches to the kernel containing intentionally introduced vulnerabilities as part of an academic study on whether malicious code could slip past the review process undetected. When the kernel community discovered what had happened, the reaction was swift and severe. Greg Crowa Hartman publicly condemned the practice for wasting maintainers' limited time and damaging the trust that the entire open source contribution model depends on. Every patch the university had submitted was reviewed and reverted, and the University of Minnesota was banned from contributing to the kernel altogether. That incident is still referenced today as a cautionary example of what happens when someone treats the kernel's review process as something to be gamed rather than respected. That history matters here because it explains why assisted by exists as a disclosure requirement rather than the kernel community simply trusting developers to self-regulate quietly. The kernel's entire review culture is built around one core principle. Maintainers need to know exactly what they're looking at so they know how carefully to look at it. A patch written entirely by an experienced kernel developer with 15 years of history in a specific subsystem gets reviewed differently than a patch from a first-time contributor. AI-generated code introduces a third category entirely. Code that can look confident and technically fluent while still containing the kind of subtle logic errors an inexperienced human contributor might never produce in the first place, because AI models don't make mistakes the way humans do. They make different mistakes, and reviewers need to know to look for them. What makes the Linux kernel's response particularly notable is the tone it struck. Croa Hartman himself has publicly acknowledged that these AI tools have genuinely improved, and that a lot of what's now coming in isn't junk anymore. Some of it is legitimately useful, catching real bugs that might have taken a human much longer to find. He's even been running his own experimental AI-assisted fuzzing setup, informally nicknamed Clanker, targeting specific parts of the kernel's networking and file sharing code, specifically to surface real high-value bugs. This isn't a community trying to keep AI out. It's a community trying to formally define the difference between AI as a genuinely useful tool in a disciplined process, and AI as a shortcut around the discipline that has kept one of the most widely deployed pieces of software in history secure and stable for more than 3 decades. That distinction, tool versus shortcut, is really the whole story here, and it's exactly where the Microsoft comparison becomes so pointed. GitHub Copilot, and Microsoft's broader internal push toward AI-assisted development, has been marketed heavily around speed, write code faster, ship features faster. Let the AI handle the boilerplate so engineers can focus on higher-level problems. That's a completely reasonable pitch for a lot of software. But the Linux kernel operates under a different set of stakes entirely. A bug introduced into kernel code doesn't just affect one company's product. It potentially affects every Android phone, every cloud server, every embedded device, and yes, every piece of Microsoft infrastructure that happens to run on Linux somewhere in its stack, which, given how much of the modern cloud runs on Linux, is a lot of infrastructure. This is also where the irony deepens even further, because Microsoft's own relationship with Linux has already gone through one enormous transformation. This is a company whose CEO once publicly compared open source licensing to a disease. Decades later, that same company now ships its own Linux distribution for internal infrastructure use, builds a Linux compatibility layer directly into Windows, and owns the platform, GitHub, that hosts the Linux kernel's own code today. Microsoft's relationship with Linux has already been a story of reversal once. Now, with this new AI coding policy, there's a second layer of tension forming. The platform Microsoft depends on and profits from through GitHub just formally drew a line around the exact kind of AI-generated development culture Microsoft has spent years encouraging inside its own walls. To really appreciate how big a shift Microsoft's relationship with AI-generated code has been, it helps to zoom out for a second. GitHub Copilot launched broadly in 2022, built on OpenAI's models, and Microsoft has spent every year since then pushing it deeper into how software gets written, both by its own engineers and by the millions of developers using GitHub worldwide. Microsoft's own public statements and developer conference presentations have repeatedly emphasized how much of the code written across its ecosystem now involves some level of AI suggestion or completion. Internally, using Copilot hasn't been treated as optional or experimental. It's been positioned as the default modern way to write software at the company that owns the platform. That's a meaningfully different philosophy than the one the Linux kernel just formalized. Microsoft's public messaging around Copilot has largely emphasized velocity and productivity gains, writing more code faster with fewer keystrokes. The kernel's new policy explicitly pushes in the opposite direction on accountability, even while allowing the same tools. It doesn't ask, how much faster can this make us? It asks, who is responsible if this breaks something? And answers that question in a way that puts the entire burden back on a human being, every single time, no exceptions. It's worth being precise about what this policy does and doesn't prove, because it would be easy to overstate it into a bigger conflict than it actually is. This isn't Linus Torvalds declaring war on Microsoft, or the kernel community publicly calling out any specific company by name. The Coding Assistant's RST document doesn't mention Microsoft, Copilot, or any single company or product anywhere in its text. It's a neutral tool-agnostic policy that applies exactly the same way whether a developer used Copilot, Claude, Gemini, or any other AI system to help write their patch. But policies like this don't need to name a company directly to send a message. And in this case, the message lands with particular weight on Microsoft, specifically because of how central AI-generated code has become to how Microsoft describes its own engineering culture in public. When one of the most rigorous, security-critical, and widely deployed software projects in the world formally decides that AI-generated code needs stricter accountability rules than human-written code, it's a quiet but pointed statement about where the rest of the industry might eventually need to follow, even the companies that have been moving fastest in the opposite direction. There's also a broader pattern worth mentioning here, because Linux rarely operates in isolation when it comes to setting norms for the rest of the open source world. Historically, when the kernel community formalizes a new process, whether it's around licensing, security disclosure, or contributor conduct, other major open source projects tend to watch closely and often adopt similar frameworks themselves. Given that projects like Python and curl were already independently wrestling with the exact same AI-generated content problem, there's a reasonable chance that the kernel's coding assistance.rst document becomes something of a template. If that happens, this becomes less about Linux drawing one line in one project, and more about the beginning of an industry-wide standard for how AI-generated code gets held accountable. A standard shaped in large part by a community that has spent 30 years building one of the most battle-tested engineering cultures in software history. There's another angle worth exploring here too, which is what this policy actually looks like in day-to-day practice for a developer submitting a patch. Under the new rules, if someone uses an AI tool to help write a piece of kernel code, they need to include the assisted by tag directly in their commit message, specifying which AI agent was used and which model version generated the assistance. That single line of metadata does a lot of work. It means a maintainer reviewing hundreds of patches a week can immediately see which submissions involved AI assistance and calibrate their review accordingly, checking more carefully for the specific failure patterns AI tools tend to produce, like subtly incorrect edge case handling, plausible looking but wrong comments, or code that technically compiles but violates conventions the kernel has enforced for decades. That last point about coding conventions turns out to be a bigger deal than it might sound. The Linux kernel has one of the most detailed, strictly enforced style guides of any major software project in the world, covering everything down to how curly braces are placed and how variables are named. AI tools, trained on a huge variety of code from across the internet, frequently default to conventions that don't match the kernel's specific house style. Different indentation habits, different bracing choices, or code structured in ways that prioritize cleverness over the plain, boringly readable style the kernel has favored since the 1990s. The policy explicitly states that AI-generated code has to conform to all of the kernel's existing style requirements, just like human-written code does, and that attributing a style violation to the AI tool that produced it isn't an acceptable excuse during code review. In other words, the tool doesn't get a pass just because a machine wrote the offending line. The human submitting it still owns the outcome completely. This is precisely the kind of granular, unglamorous discipline that doesn't always translate into flashy headlines, but it's exactly what makes the kernel's approach so different from the move fast philosophy that companies like Microsoft have built entire product lines around. Copilot's pitch to developers has never really been about matching your team's exact 15-year-old style guide down to the letter. It's about getting a working suggestion onto your screen as quickly as possible. Those are two fundamentally different sets of priorities, and the Linux kernel just made it clear, in writing, which side of that trade-off it's choosing for one of the most important pieces of software on the planet. It's also worth acknowledging that this isn't purely a story about caution winning out over speed. The kernel community isn't rejecting the productivity case for AI tools. Multiple maintainers, including Croa Hartman himself, have said plainly that these tools have become genuinely useful, sometimes catching real bugs faster than a human reviewer would have on their own. The policy isn't trying to slow innovation down for its own sake. It's trying to make sure that as AI tools get folded into one of the most consequential code bases in the world, the same standards of human responsibility that have applied for 30 years keep applying, regardless of how the code actually got typed out in the first place. So where does that leave Microsoft? Not banned, not blocked, and still very much a major contributor to the Linux kernel, but standing in an unusually exposed position, watching one of the platforms it depends on and profits from draw a formal documented line specifically targeting the kind of low accountability, AI-generated development pattern that its own flagship coding tool has spent years encouraging as a competitive advantage. Microsoft built Copilot to make AI-generated code feel normal, fast, and routine. The Linux kernel just spent months formally deciding that when code shows up without a human standing fully behind every line of it, normal isn't good enough anymore. Whether the rest of the industry follows the kernel's lead, or whether this stays a Linux-specific policy while everyone else keeps moving at Copilot speed, is genuinely an open question right now. But for a community that has survived licensing wars, corporate hostility, and decades of skepticism about whether volunteer-driven software could ever be trusted to run the world's critical infrastructure, writing down a clear, disciplined answer to the AI question fits a pattern that's been playing out since the very beginning. Linux moves carefully on its own terms, and lets everyone else decide whether to catch up. There's a certain symmetry to how this story lines up against the earlier chapters of Microsoft's relationship with Linux too. In the late 1990s, Microsoft's leadership publicly treated Linux's entire development model, open, collaborative, distributed among volunteers with no single company in charge, as something closer to a threat than a legitimate way to build serious software. The assumption baked into that skepticism was that Linux's loose, community-driven process couldn't possibly produce the same discipline and reliability as a single company tightly controlling its own product. 3 decades. Later, it's Linux's community-driven process that has produced one of the most rigorous, explicitly documented accountability frameworks in the industry for handling a brand new technology. While a lot of the corporate software world, Microsoft very much included, has spent the last few years racing to fold AI-generated code into daily workflows first and figure out the accountability questions later. That's not a small reversal. It's almost a direct inversion of the original argument. The company that once questioned whether volunteer-run open source could ever match corporate software's discipline is now watching that same volunteer-run project write the playbook for exactly the kind of discipline the AI coding era actually needs. While its own flagship AI coding product keeps shipping millions of suggestions a day, built on a philosophy of speed that the kernel just formally decided wasn't good enough for its own codebase. None of this means Microsoft is doing anything wrong, exactly. Different projects can reasonably choose different trade-offs between speed and rigor, depending on what they're building and who depends on it. A marketing website doesn't need the same level of scrutiny as an operating system running inside pacemakers, cars, and nuclear power plant control systems. And Linux runs in all three. But it does mean that when people ask which philosophy is actually going to define how the software industry handles AI-generated code over the next decade, there are now 2 very different, very public answers sitting side by side. Microsoft's velocity-first Copilot culture and the Linux kernel's newly written insistence that no matter how the code gets typed, a human being has to stand fully behind every single line of it. One more thing worth watching closely going forward. This policy is brand new, which means it's still essentially untested against a real high-profile failure. The kernel community has written down what should happen when AI-assisted code goes wrong. Full human accountability, no exceptions, no excuses tied to the tool that helped produce it. But policies like this tend to get their real test not on the day they're published, but the first time a serious bug, traced back to AI-assisted code, actually makes it into a released kernel version. And the community has to decide in public whether the accountability framework holds up under real pressure. Given how much scrutiny this document already received before it was even merged, it's a safe bet that if that moment comes, it will be watched just as closely as the policy's original announcement was. If you found this breakdown useful, consider subscribing for more deep dives into the ongoing relationship between Microsoft, Linux, and the open source world. And let me know in the comments, do you think Microsoft's own AI-assisted coding culture can adapt to rules like this, or is this the first real crack in how much the industry has been leaning on AI-generated code without asking hard enough questions about who's actually accountable for it?